So what are we going to talk about today, Mike?
Yes, George, we are going to talk about refrigeration, why we refrigerate, principles of refrigeration, get into some troubleshooting, but refrigeration is huge in the beverage industry. So why do we refrigerate?
Probably one of the keys is going to be for taste, because if we don't have good carbonation and it goes flat, you're not going to get that same taste out of there. The carbonation enhances both the smell and the taste of our drink.
That is right. And also with carbonation, CO2, we know we should already know with basic fountain, our temperature needs to be below 40 degrees to get the CO2 molecules to bond with our minerals in the water, right?
Yeah, absolutely. Because 40 degrees is that bonding point. Anything above the CO2 and the water molecules will not stay bound together. And it's, as soon as you pour that drink, it's just going to go flat as the CO2 escapes. So we need to keep it below 40. But the key is to remember 40 is that bonding point. We really want to have it less. And Coke recommends to have our drinks down at 36 degrees.
Let's get into the principles of refrigeration.
First principle is heat's a form of energy, and energy cannot be destroyed. It can only be removed and moved to a less objectionable place or substance.
Right. So technically, we're not cooling something down. We're removing that heat. In return, it feels cold, right? So I always say in class, put an ice cube in your hand, close your hand. What is happening? And everyone says, oh, my hand's getting colder. It's like, no, what's technically happening is that ice cube, which is a solid, as it's melting, it's removing that heat from your hand. In return, the ice cube starts melting into a liquid. So it's transferring that heat out of your hand and melting that ice cube.
Yeah, another principle that we have to look at, and it's really one of the main principles when dealing with refrigeration, is going to be heat transfers from a warmer to a cooler space. So if you don't understand that, it's really going to be hard to be able to diagnose your mechanical refrigeration systems, because one thing you're going to realize is the hotter something is, the more heat it puts out, it's going to get rid of that heat. And from that point, it's going to move to a cooler location. We'll see that inside the cooler as we're trying to cool it down. It's going to take the heat that we have inside maybe a cooler, and it's going to move that to the refrigeration system, and then the refrigeration system will move that outside of the cooler itself. And it's moving from a warmer to a cooler space. And we'll talk about that as we go on through the principles, but you have to understand that one.
It's kind of weird because almost like it's backwards, right? It just doesn't seem.
Well, it almost sounds that way, because you're thinking, okay, how is it warmer like inside a cooler than it is outside? But it's a couple different parts, because the air inside a cooler or a vending machine would be warm compared to the refrigerant. The refrigerant's going to be very cold. So the air is going to give up its heat to the refrigerant flowing through the cooler. And then as the refrigerant moves to the outside towards the condenser coil, what's going to happen is the refrigerant will become extremely hot at that point. It'll be hotter than the air outside, and again, move from a warmer to a cooler place. So like I said, as long as you can remember the principle of moving from warmer to cooler, once we get into talking about mechanical refrigeration, I think it's going to make a lot more sense.
That's right. So let's talk about that heat transfer. So we have three types of heat transfer. We have conduction, convection, radiation. And we can see all three heat transfers in our equipment here at Coca-Cola. Conduction's touch. So we use conduction in our ice combo machines, our drop-in units. That's where the ice is touching our cold plate. So in our units, we have, ice, it's ice cooled, but it's removing that heat from our product lines and our CO2 or our soda water. And that's through conduction. And what happens is ice cubes melt. It removes that heat, and it turns from, again, a solid ice cube to your ice water melt going down the drain. So technically our heat, when it's removed, is going down the drain.
Yeah, and that conduction part is a really important part, because we need to have ice completely across that cold plate, and it has to be contact completely across. I've
Yeah.
been to locations where they only have half an ice bin and they're wondering why their drinks are not coming out at the optimal temperature or not tasting perfect because we don't have enough ice. We do not have that conduction completing throughout that.
Yeah,
So
and
Yeah.
what we'll see is warm drinks. So on a service call, might have to take a look at your ice. Do you have good contact with your cold plate?
Yeah, it goes back to that principle of refrigeration. We talked about moving from warmer to cooler. You got warm product coming on into your equipment, goes through the cold plate. That warm product gives up its heat to the ice. And then by doing that, it's actually cooling the product. It's losing its heat as it gives it up to the ice.
Exactly. Second heat transfer is convection. Convection's either through air or water. So we see both again in our equipment. So if we look at a vending machine, that cabinet in that machine, nice and warm when we start up the machine, but as our refrigeration works, we're going to remove that heat from that enclosed area, and that heat is going to be transferred out into the atmosphere, and that's through convection, air or water. So if we have a counter electric unit, it has a water bath in there where our lines are going through that water bath, and we're removing our heat. Instead of ice cooled, we're using that water to remove that heat.
Conduction, we're seeing that with ice combos and drop-ins. Convection, we're going to be seeing that like coolers, vendors, uh, uh, counter electric dispensers, remote refrigeration systems. But how about our last one there, George? Radiation.
So radiation, for an example, would be something maybe shines in, right? We don't really use radiation so much, but we have to be very aware of what radiation can do. If we have our machine sitting near a window, say for instance, we have a counter electric sitting near a window that is projecting sunlight in on the machine. Now all of a sudden it is heating everything up. And it's going to take more for the product that's inside of the machine that's been heated up by that radiation to get cooled back down. So it is still a heat transfer.
Yeah, I always relate it to, let's say in the wintertime, especially in Ohio right now, where it's very cold outside, but I can get in my car, and when that sun is radiating through the windshield, it feels nice and toasty in my car. But then you open that door and reality sets in. But yeah, like a greenhouse effect that's radiating through that glass. And if we do equipment placement, maybe a cooler right in the business's front door by the window, and maybe in the afternoon that sun shines through, it can warm up our product through radiation.
Yeah,
So
one
you're
of the
exactly
biggest
right, George.
yeah, one of the biggest issues that you are probably going to see with that situation is the fact that as the bottles are warming up, but are still being cooled by the mechanical refrigeration system, that hot air and cold air are going to mix. And then that is going to cause condensation, which may be called in as a water leak underneath your machine.
Do you condensate, Damon? There's a lot of hot air.
Yeah, lots of hot air, especially here in Ohio, when it's like negative something outside. What was it the other day? It was negative 14.
Yeah, it was a little chilly.
Oh. All right. So, what types of cooling are we going to be looking at?
So Damon, yes, we have two types of cooling. We have ice cooling and we have mechanical cooling in our equipment. So with ice cooling, like we mentioned, we're using those ice cubes to remove the heat from our product. I do want to mention that there is such thing as hard ice and soft ice.